Hey, chemistry. I found this nice little simulation that puts the ideal gas law together with phase diagrams so that you can see what it actually looks like. Remember, in a phase diagram, we can see these different points in solid, liquid, and gas. We can see that adjusting the pressure or temperature could cause a phase change. So what this simulation gives me is a way to relate the pressure, temperature, volume, see I can lower the volume of this whole thing, and the number of moles. See, I've got this little air pump so I can put more in. Okay, so I'm going to pump it up, put a whole bunch in there, and I can see on my phase diagram I am changing my temperature. So my temperature is going up, so it's showing me where that's happening. I can intentionally increase the temperature, so my temperature is going up even more now. We can see that. I've got kelvins up here. I can change that to Celsius if I want. Or I can cool this thing down. Now, right around here, this should be the liquid phase. And we can see that it is the liquid phase because these molecules are all moving around. They're moving around each other pretty freely, but they're all still in one lump. If this was the gas phase, let's see if we can make it do that. Let's pump up our temperature. Past 373 should be a gas. So we can see now it's starting to spread upwards. Give it a little more energy. Up, because our pressure is up, that's why. And now they're moving all around the container. Now that's a gas. I could drop my temperature down even more. Doop, 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 doop. Dropping it down, dropping it, dropping it, dropping it. We can see that the atmospheres are going down as well. The pressure is dropping along with the temperature. If I drop it down low enough, now, hey, look at that. Now we're a solid. What I really like about this simulation is that you can also change it to oxygen, argon, or neon. But when you're using the water, water is a polar molecule. And so when it freezes, when these water molecules have to be in a certain spot relative to each other, what happens is they line up to maximize their hydrogen bonding. And so they end up making this really interesting lattice structure. So this is a solid. This is solid water. But notice, when I heat it up, get it to become a liquid, it condenses. It becomes less dense. Water is one of the few materials that actually becomes less dense when it freezes, which is why ice floats. Like, it's so common that we don't think about it, but ice floating is really weird. Like, if you put solid iron into molten iron, the solid iron will sink. If you were to, I guess, if you were to freeze oil, which sounds disgusting, the solid oil wouldn't float. Water is really weird. It's not a common feature for the solid form of a substance to float. So we can look at how all of these concepts relate to each other. So I think it's really helpful because not everybody can just see an equation and see how those things relate. That's why I really fell in love with physics, but I know that's why a lot of people struggle with it, because they don't just see it in their head. So visualizations like this can really help us. So I can see that as I pump up my temperature again. Let's just go through this one more time. If I pump up my temperature, bloop, 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 get it up there, come on, you can do it. Until my pressure starts to increase. What's really happening with my pressure increasing is it's going to increase the more these molecules are bumping against the sides of the container. So if I make the container smaller, then they're going to bump against the sides more often, so my pressure is going to go up. If I make the container larger, they'll have more room to move around, and so the pressure will go down. If I heat them up, I give them more motion. When I heat up, remember, when I heat up a gas, I'm really giving more energy to each of the molecules. And so if I give them all that energy, they're going to move around more, they're going to move around faster, and so they're going to bump into the sides more, so the pressure is going to go up. If I put more of them in there, well, there's going to be more molecules to bump into the sides, and the pressure will go up. Same thing. And if I try to, what's fun about this simulation is if I try to break it down too much, then, oh no, the whole thing breaks open and it's all done, and then I can return the lid and start over. Cool. Thanks, guys.